MySQL, MySQL, Oracle, PostgreSQL. Are you guys confused regarding what is the difference between these platforms and when to use which platform? Hello, my name is Sumit Shukla, and in this particular video, I'll be clearing your confusion. But before we start this video, don't forget to check out Scalar's free masterclass on Scalar's event page by industry leading experts. The link is in the description box. In this particular video, we will first understand the concept of database, the difference between client and server, and what exactly is SQL. Then we'll be trying to understand the difference between various SQL vendors. Before we start this video, don't forget to subscribe to our Scalar's YouTube channel. Let's first of all understand the problem, why RDBMS was invented and why people need RDBMS. So we will start with the example of a multinational company. Since we all are very much aware about companies like Amazon, I would take the example of Amazon. So here we have the company Amazon. Now, let's say let's say the company Amazon has recently started, and as of now, they are using a traditional storage system. Now, what is traditional storage system? Let's say the company is preferring to use Excel files to store their data, maybe PDF files, maybe pen drives, or maybe hard paper document. Now these all technologies, or maybe I would say the storage options, are known as traditional storage system. Now, if Amazon is using these traditional storage system to preserve their user data, or maybe to preserve their data about everything, about their orders, about their customers, about their payment methods and everything, what all problems the company would face. And you can pause the video and can comment your answers. Maybe you can let us know what all problems the company would face. If we talk about the major problems, the very first problem is the data size is huge. As you guys already know that data is humongous. So let me write it down. Data size is huge. And the data is growing at an exponential rate. So every day Amazon would have a bulk of data to preserve, and these traditional storage system comes with a limitation. So they will not be able to accommodate everything in these traditional storage systems. So that's a very general problem, the very first problem that they would face. Now the second problem is with the management. As the data is growing exponentially, managing all these Excel files would be a very great problem. Where to keep all these files? Where to preserve them so that, first of all, it is secure, it is not getting distorted, it is not getting exposed to some of those people who are not authorized to use them. So there are a lot of problems and challenges to manage all these files. Now the third problem that the company would face is security, as I was talking about in the last point. But the major problem that the company would face is regarding the same view of the data. Now what is same view? As you already know, Amazon is a multinational company. Multinational means they have offices across world. So let's say Amazon is having their office at USA. Now here we have the USA office, and here we have the India office. Now let's say there is a person, let's say this is me, Sumit Bhaiya. So let's say there is a person, Sumit, who is sitting in USA office working on a particular project. I'll name this project as P1. Here we have another person. and her name is Shreya, and she is also working on the same project P1. Now they both need to work on the same data file. So what Amazon has done, we have to assume right now that Amazon does not have any technology to make the same data available to both of them. Or maybe the same data is accessible to both of them. So what Amazon has done as of now, they have provided the copy of the same file. So here we have the main file. I would call this as main file. And one copy is provided to Sumit. So I will call this as C1. Another copy is provided to Shreya. I'll call this as C2. Now, what is the problem? The problem is any changes made by Shreya in her copy, which is with her, the C2 file, will not be replicated or will not be available to Sumit in his file, which is C1. Similarly, if there are any changes made by Sumit, it will not be visible, it will not be available to Shreya. So the analysis that will be done by Shreya and the analysis that will be done by Sumit will be two different things because they have not been provided with the same version or the same view of the file. And that is the major problem. How to make the same data, the same view of the data available to everyone who is trying to work on the same file. That's very important problem. The second problem is with the management of the data. How to logically arrange the data. So let me call this as problem number 4, the problem that we have just discussed, the same view problem. The same view problem. And I would color it in red so as to mark it as a very important and maybe the very difficult problem to resolve. Now, coming back to the last problem, like there are multiple problems actually. We cannot talk about everything. So here we are trying to discuss the most difficult problem in the sequential order, starting from very difficult to least difficult. So the fifth problem is logical collection and arrangement of the data. Logical collection and arrangement of the data. Now for this also I will use a red color to mark it as very much important or maybe most difficult problem to resolve if the company wish to use traditional storage system. Now before I move forward, let me just recap. Here all the problems that we are right now talking about talks about the traditional storage system. If a company, any company prefers to use these traditional storage systems, what all problems the company would face. So when it comes to logical collection and arrangement of the data, let's say, so Amazon has multiple business, right? Let's take one of the business, which is e-commerce. Now you guys already know that in e-commerce, various customers would place various orders. So we have the orders data. Then each order would have the customer's data. So which order was placed by which customer. So we have customer's data over here. Then we will have the customer details like what is the name of the customer, the email ID, the password, and mobile number, and other customer-centric information. Then each order will be associated with a product. Now, which product was ordered? So let's say product number 1 was ordered and this customer ordered product number 1. So there will be product details. Then each product will be associated with a vendor. As you guys already know that Amazon is a marketplace which connects various vendors to the customers. So each product will be linked to the vendor who has placed this product in the website. Then we will have the vendor centric information, like who is the vendor, how many orders or maybe how many products he has placed in the website. We will also have the delivery partners. So each order will have the delivery partner details. Now here you can see that we are creating a mesh, and then it is like a network where each data point is connected to another data point. If I try to preserve the data in this format using Excel files, using PDF files, using pen drives, I would certainly not be able to do it. The reason is we do not have any mechanism which can let us preserve the data in this kind of format. And that is what the fifth problem is: logical collection and arrangement of the data. How to logically arrange this data in such a way that it is easy to input and it is easy to retrieve the data. Because if I'm trying to preserve my data, my objective is not to just preserve, my objective is also to retrieve that information so that I can perform the analysis and find out some interesting insights from the data. And that is why any company preserve the data, so that later it can be utilized to find out interesting information, right? So these are the major problems that was present before the invention of RDBMS. Now, how these problems were resolved? In order to resolve these problems, the technology that came into existence, and this technology happened to be invented in 1970. I will tell you the history of how this technology was invented, who invented, but right now let's try to focus on what this technology was. The technology was named as RDBMS. It is named as Relational Database Management System, RDBMS. Okay. Now, RDBMS as a technology comes with two components. The very first component that is a part of RDBMS is known as the server, and the second component is known as the client. Server and the client. Now let's first of all understand what is a server. Server is basically the central storage of the data. Now please remember one thing: the explanation that I am making right now is according to the latest architecture of RDBMS that exists today. So I'm not talking about 1970s, because in 1970s the technology was different, the architect was different, and whole technology and whole process was different. So right now we are talking about the latest technology and how RDBMS systems work today. So right now today we have a server and we have a client. Now what is server? Server is basically the central storage of the data. So this is a server and this is a central storage. So I'll write central. Now, if you guys haven't looked into any kind of server, you guys can quickly check out Google Data Center, and there is a video which will help you to understand how a Google Data Center look like. But I have some pictures over here which can help you to understand. So this is how a data center or maybe a data warehouse looks like. You can see that over here I have a lot of boxes. Now these boxes over here, these boxes are known as racks. So here we have one such rack. This is a rack. And each rack is having a lot of computers connected together to create a huge network of storage plus processing power. So here you can see that each entity over here, so this is 1, this is 2, this is 3. Let me write it over here. This is 1, this is 2, this is 3, and so on. These are basically individual computers, and all of them are connected together. You can see that all of them are connected together with these overhead wires, right? When they are connected together, they create a huge network of storage space and processing power. And that is what is known as a server. Now, assume that you have a central room where you have so many computers connected, you have a very huge storage space, and you can connect to that storage space using your ID and password. That is what a server is. So, this is a centrally located storage system present anywhere in the world. Right now, Google operates so many data centers across the world. Even IBM has a data center. Companies like Amazon has a data center, and there are multiple data centers present across the world. So we can assume right now that we have one such data center of Amazon, which is centrally located in, let's say, USA. Now, here I am sitting in India, and here is my laptop. Now, in order to connect to this particular server, I need a software on top of which I can enter my username and password, and I'll be able to connect to the server. So I need a software that can run on my laptop. So let's quickly create a interface of software. So this is my software. Now this software will connect to the server. This software is known as the client. So if I talk about client is basically the software or the UI. It is also known as GUI, graphical user interface. So I'll write GUI. So it is GUI, graphical user interface, that runs on the user's laptop. Now, on this particular software, which is client, the user can input his or her credential, and that will let the user connect to the server. Once the server is connected, once the user is connected to the server, the user can communicate the requirement to the server that, hey server, I need XYZ details, or maybe, hey server, please return me the top 10 customers who has made the purchase, or maybe, hey server, please return me the top 10 products that have sold yesterday. But the problem is how we can write this, or how we can talk to the server, how we can communicate our requirement to the server. In order to solve this problem, the language was created, and this language is known as SQL. So please remember one thing, SQL is not a programming language, it is a communication language. SQL is used to build a communication between the client and the server. So whatsoever information I need from the server, I will write down in the SQL format. I will write down in the SQL query that will be communicated to the server. See, server will process it and it will return it to me. So SQL comes over here, which act as a communication language between the user and the server. So let me write it down. SQL, which stands for a structured query language, which is a communication language that act as a bridge between the user's requirement, which he or she will write down in the form of SQL query, and the server. So this is basically a language that is happening between these two components. Now, the first problem is resolved, that okay, we have the central storage, all the data is present in the central storage. So anyone who wanted to query that data or maybe check out that data can log in and can check it out. So my problem number 4, which was over here, is resolved. So I'll write tick, it's done. But what about this problem, 5th number problem? How the data is logically arranged. Now this is something that is what the architecture of RDBMS is. If we try to understand the architecture of RDBMS, it is very simple. Let's understand this within a very layman example. Over here, okay, let's say Amazon is having multiple business, and it is having multiple business actually. So I'll write down e-commerce over here, e-com, and then Amazon AWS, then Amazon, let's say Amazon Entertainment, ENT, then we have Amazon Pay, the financial services. Now, within each of these business, Amazon will be having multiple data sets or maybe multiple sources of the data which the Amazon has to preserve. If I take a very simple example, let's say I'm having some files or maybe I'm having some photographs. Let's say I have some 1,000 photographs, out of which some photographs belong to me. So Sumit's photograph. Some photographs belongs to my girlfriend. So Sumit's GF. Some photographs belongs to my parents. So Sumit's parents. Some photographs belongs to let's say my father, or maybe let's say my brother. So Sumit's brother. Now let's say this is my laptop. So what is the best logical way to preserve all this data, all these files, all these photographs into my laptop? And let's say I'm talking about the D drive of my laptop. Now, if you guys think about it, the best possible way is to create folders. So I have created folder A, folder B, folder C, folder D. And I can place all the photographs of myself in A, followed by all photographs of girlfriend in folder number B, then folder number C, and then folder number D. Now this is the best possible way to logically arrange this data in my laptop. Now the same architecture or maybe the same logic is used by database. In your RDBMS infrastructure, we have two components. So here these are known as files, and these are your folders. So in your RDBMS infrastructure, let's say these are my folders, and each of these folders will have the associated files. Let's say in e-commerce, we will have the files of orders, the orders data, the customers data, followed by vendors data. So these are my files. So RDBMS follows what is known as the folder file format. Folder file format. Now in the RDBMS term, these folders are known as database, and these files are known as the tables. And this is what are the two initial components of a RDBMS or maybe of a server. So in the server, you will find of multiple databases. So for example, Amazon is having multiple business. So it will create multiple databases, and within each database, it will have multiple files, which are also known as tables. We will talk more about what are the tables, how tables look like, and how they are connected to each other in the next slide. Now we are able to resolve the two major problems. Let me just quickly summarize because you guys must be feeling confused now? So let's quickly summarize everything. We started discussing about what are the problems and what all problems the company would face if they prefer using traditional storage system. The two major problems that we came up with was the same view problem, how to make the same data available to everyone who wanted to query that. The second problem was logical collection and arrangement of the data. How to logically preserve the data so that it is easy to input the data and easy to retrieve the data. We started discussing the solution, and the solution was RDBMS. RDBMS comes with two components, the server and the client, where server is the central storage of the data and client is the software or the GUI that helps the user connect to the server. SQL is a communication language that acts as a bridge between the client requirement and the server. So whatsoever requirement the client is having, he or she will write down that requirement in a form of a SQL query that will be communicated to the server, and the server will process it to return the answer to the client. Now, how we were able to solve the first problem, the same view problem. So the same view problem was resolved by creating server, which was the central data storage, and everyone who wanted to access that data can connect to it. The second problem was resolved by creating these architecture, which is the folder file format. We have database, we have within each database we have multiple tables, but the problem is still not resolved. How the logical arrangement will happen within these tables so that this kind of mesh like a structure is preserved, because you can see that there is a network. The order table is connected to product, product is connected to vendor, and so on. So how this network can be preserved? In order to preserve this, we have to understand the tables. Now let's take an example of a company database. So let's say we have this table. This table is having employee ID, name, joining date, salary, and the last one is the department ID. Now let's say we have multiple data entries or rows. So here this table is named as let's say the employee table, because it consists of all the employee specific information. And then we have the departments table. So here we have the department ID. Here we have the department number. And then let's say we have number of employees. So let's create some data points. Now, before I talk about how these tables are related, let's talk about the terminology associated with these tables. Please remember that these two tables are the part of a database, the company database. So this is my table number 1, which is named as employee table, and this is table number 2, which is my departments table. Now in this particular table, these columns are known as fields, while these rows are known as records. Now these are the terms used for the table which is a part of a database. Fields are your columns and records are your rows. If you guys carefully observe, we can find out a common column within these two tables. This particular column, which is department ID, is available over here as well as available over here. Now this is what is known as the relation. This particular common column will act as a relationship between these two tables. So if I ever wanted to connect these two tables to extract the complete information, I can simply use this common column to connect these two tables. Now in the department table, in this particular table, which is departments table, this column has a very special name, or this field is known as the primary field. Now it is known as primary field because in order to input any record in this particular table, I need to declare the department ID. Without having department ID, I cannot enter any record into this table. So a primary field cannot be null, not null, and it needs to be unique. These are the two constraints of a particular column or a field to be a primary field. A particular primary field of one table, so here department ID is the primary field of department table, becomes foreign field. So this is my foreign field. Becomes foreign for the another table. So the definition of foreign field is a particular primary field of one table becomes foreign field for the another table. Now the combination of these two columns, which is a primary field and the foreign field, will establish the relationship. And that's how multiple tables are connected within a database. So if I quickly show you a schema, maybe within a database. So within a database, how multiple tables are connected. Here you can look at a sample schema. So this is known as a schema of a particular database. So here I'm having the customers table, orders table, order item table, and product table. Now here you can see that in the customers table, this ID is the primary key. This particular primary key is connected to this column, which is customer ID. So this is foreign. I'll write F over here. I'll write P over here. Now for orders table, this is the primary key, which is connected to the order item over here. So this is my foreign, and this is the primary key, which is the order item ID. Here again, you can find out the relationship between the product ID. Here it is foreign, and here it is primary. So you can see that all the tables in this particular schema are connected to one another, and we can fetch out the complete information about the detailed information about any product, any customer, any order by connecting all these tables. That is how the data is presented within a database. So this is how RDBMS resolves all the problems that comes if I use traditional storage system. Let's now understand the concept of vendors. Now to understand this concept, we will first of all take a very simple example. So you guys consume coffee, right? So we have coffee. Now coffee as a product, you can find out coffee from the vendor Tata. You can find coffee from the vendor Brew. Then we have Nescafe. Then we have other brands coming into picture. So we have multiple brands and we have multiple vendors. Those who are basically selling the same core product. So the product over here is coffee. The core product is coffee. Now you can consume coffee from any brand which you want. Now what they essentially have done, they have added some flavors, some extra flavors, and they have presented their coffee better from other. So how we decide that we are going to have coffee from Tata, or how we decide we are going to have coffee from Nescafe. It depends on our taste, our convenience, and our choice. The same concept goes with RDBMS technology. Now, RDBMS is a technology for which we have multiple vendors. We have Oracle, we have MS SQL, also known as MS SQL Server. Then we have MySQL. Then we have PostgreSQL. Now, these are the vendors which are basically running in the market. They are the market leaders when it comes to the RDBMS technology. But how it all started, or maybe who was the first person, I would not say person, who was the first company who developed this technology for professional use, for the commercial use. So let's try to understand the history. Now, history is something which is very important to understand, to be known, because it will give you an idea about how the development was made in technology. It is not a very important interview question, but it is very important for any technology experts, or maybe as a data professional, that we are aware about how the developments has been made in the technology. So that is very important. Now, this person on your screen right now, this person is named as EF Cod, and he is the father of the technology RDBMS which we are using today. So in 1970, this person presented a paper named A Relational Model of Data for Large Shared Data Banks. Now, when he presented his paper, there was a lot of disruption in the market, because at that time the technology that the market was using was very much bulky. Now, when I say bulky, that basically means it was not scalable, it was not organized. But this person, when he presented his paper in year 1970, the technology, or maybe there was a disruption in the market. Everyone was trying out to implement this technology. Since this person, right at that particular time, was the employee of IBM, he reached out to the managers and the maybe the leading team of IBM. So I'll write M over here to depict managers, and he presented his idea to the managers. So he was basically trying to convince the IBM team so that the IBM team can start working on his idea and can develop a product out of it. Now, what happens, as you guys already know, if a company has to work on a new technology, the company has to put some extra money, and that was the concern of the management. So the management straight away discarded, and the management was not interested in his idea. EF Cod started reaching out the clients of the IBM company. So IBM was basically a company which was serving to multiple clients at that time. And when EF Cod started reaching out to the clients, they got an idea that this is a technology which can help them to basically modify their existing database management system. And they got an idea that this is something that can help them to scale at an exponential pace, because at that time the data was growing at an exponential rate. So there was a lot of pressure that created on top of the IBM management, and that is where in 1974 the company actually started a project named as System R. And one thing which was shocking at that time was this project was not having EF Cod as a team member. So they started this project without EF Cod. But they were actually very late in implementing this technology. By the time IBM was planning about this project, by the time IBM was working on the idea of EF Cod, Oracle came into picture. Since Oracle was already very much fascinated with the idea of EF Cod, they started implementing that project, and they became the very first company in 1979 to make this technology named RDBMS available commercially. Now that is how history started building up. So the idea was developed by a employee of IBM, but IBM, since they were not interested, Oracle took the time, Oracle took the advantage, and they developed the first commercially available RDBMS. Now, how SQL was developed? So we have to go back in this project R. So when the team at IBM was working on this technology project R, and which they were able to develop by the year 1975, they faced a problem. Now previously, if a particular client has to communicate to the server, it was required to write a very heavy code to particularly transfer the request to the server, and that was really difficult to do for a normal person. Let's say if I am a manager and if I am interested in finding out what are the top 10 products which my company is selling, so for me, being a non-technical person or maybe not a technical advanced person, writing good number of code or a huge code is a difficult task for me. So the team who was working on Project R, they developed a simplified language which they called as SEQUEL. Now that is SQL, but the full form was Structured English Query Language. And this particular SQL is nowadays known as SQL. So that is how this language was developed. Now let's come back and talk about how the vendor development happened. So as I've already told you, Oracle was the first company which came into the market and placed their commercially available product named RDBMS. Now the next, what happened? Now Oracle, when they were working on this technology, they found out that the existing SQL language has some limitations. When we talk about SQL language is designed in such a way that you can use it as a communication language, but you cannot write logics. You cannot use as a programming language. For example, let's say if I have to write a logic using if condition, using for, using, let's say I have to write a function which basically iterates. It is not possible in the base SQL, the general SQL that we all learn and implement nowadays. But since Oracle was working on this particular technology and they were looking for a language which can also implement these kind of procedural tasks, they developed a language that was named as PL/SQL. PL stands for Procedural Structured Query Language. Now the advantage of this language was that you can actually now write your logics, write your conditions, write your for statements, write your loops. You can do a lot of things with this. So here in my screen, I have presented a simple example of how a PL SQL language looks like. So we declare, then we have declared a variable var1 with the data type as number. We begin with the operation. Now variable 1 is valued at 10, so the value which we have provided to the variable 1 is 10, and then we have written a for loop to display the output, which is the multiplication between variable 1 and variable 2. Variable 1 is already 10, variable 2 is from 1 to 10. So in the first iteration I'll get 1 into 10, in second 2 into 10, in third 3 into 10, and so on. Now this is something which you cannot normally do in SQL, but this is possible with PL SQL. So Oracle is a company which developed PL SQL. Let's come back to the vendor thing, and let's first of all summarize everything that we have discussed. So this person, EF Cord, developed the idea of RDBMS system, which was first implemented by Oracle in 1979. SQL was a language which was developed by the IBM team, those who were working in the project R, and later the name was changed to SQL. Then the Oracle was the company who developed the language PL SQL. When Oracle was already established market player, why other players came into existence? So we already know that we have Oracle, then we have MS SQL, then we have MySQL, then we have PostgreSQL. Now, when Oracle was already there in the market, why other players started coming up in the market? What was the requirement? So the requirement was, the problem with Oracle was that number one, Oracle was costing a lot for the for various clients. So cost of licensing and support was expensive. It was not open source. Second was, since internet was growing at a very rapid pace, Oracle was not compatible with websites. So if I have to connect my website data with the Oracle database, it was difficult to do it. At that particular time, as you guys already know, Microsoft was a player. There were so many technology that was around Microsoft. So we were having Microsoft Visual Studio, we were having Microsoft .NET framework. So since Microsoft was a player, there was a requirement of a technology or maybe a database which is very good compatible with the Microsoft infrastructure. And that is where the second market player came into existence, which was Microsoft SQL Server. Now, when Microsoft launched themselves, the very first advantage was that it was very much compatible with the Microsoft environment, the Microsoft tools. So you can easily run it on your Microsoft Windows laptops and Microsoft Windows desktops. Also, it connects very easily with the Microsoft infrastructure or maybe other platforms that is controlled by Microsoft. But Microsoft also took one opportunity which they found that was a major gap in the industry. At that time, banking industry was facing a lot of challenges because there was transactions that were happening. So since internet was booming, banking industry was also moving towards becoming online. Now, when it comes to online, you have to manage the transactions. So what they found out that there is a lack of having a language which can deal with transactional data. So they introduced a language which they called as TSQL, Transact SQL. And the advantage was Transact SQL was that it was mainly developed to handle the transactional data. Using TSQL, we can still write the procedural logic. Writing loops, writing conditions was still simple, but TSQL was more profound and more, I would say, more easy to handle the transactional data. Now, if we compare here in this particular slide, I have shown you one example of how TSQL block look like. So we begin the transaction. If I go back and show you my PL SQL, it was declare, then begin, simply begin. But here it is begin transaction. And here in the end, you can see that if this condition is true, then we commit, otherwise we roll back. Now, what is the meaning of commit and rollback? So commit means if a complete transaction is done, then we will commit, then we will close it, then we will register that. Otherwise, we will come back. We will come back to the initial point. Let's try to understand this. What is the meaning of complete transaction and what is the meaning of rollback? So let's say we have two person. Here we have person A, and this person is having 1,000 rupees in his account, in his or her account. There is another person, person B, and he or she is having again 1,000 rupees in his or her account. Now let's say this person wants to send 500 rupees to person B. So this person initial image or initial data, I will write image 1 is 1,000. This is before transaction. This person initial image 1 is again 1,000. But when this person is sending 500 rupees to this person image number 2 will become 1000 minus 500. So 1000 minus 500, which is 500 now. This is image number 2. And for this person, the image number 2 is 1000 plus 500, which is again 500. Now this particular image 1 is before transaction. So I write BT, before transaction. This is also before transaction. And this is after transaction. And this is also after transaction. Now what is the meaning of complete process? When this person will be sending the amount to person B, and if the transaction is completed, then only the commit will happen. So T-SQL language will preserve the data when this complete transaction is done. Otherwise, rollback will happen. Otherwise, it will go back and it will show this 1000, and this person will also get 1000. So the transaction is not completed, so it will come back to image 1. Now in Oracle preserves both image 1 and image 2. So I'm talking about the difference between PL/SQL and T-SQL. The major difference is that in Oracle, your image 1 and image 2 is both preserved, but in T-SQL, once the transaction is completed, then it will preserve the after trigger. So here I have written Oracle uses after and before trigger. So this is before trigger, this is after trigger, this is before trigger, this is after trigger. But T-SQL preserves only after trigger. And the reason it preserves only after trigger is because if the transaction is not completed, let's say due to some network issue, the transaction was not completed, so rollback will happen. And the commit will only happen when the transaction is completed. Now this was the difference between PL/SQL and T-SQL. Now why next player came into market? Why MySQL? As I already told you that since internet was growing, there was a great need of having a database which is light and which can easily connect with various websites. Now when we talk about Oracle and when we talk about MS SQL, these were heavy database and they require a good amount of infrastructure to basically run them, to deploy them. But there was a great need of a very light database which can connect with any website, and also the particular user who is looking to use this particular database may not have to put that much money, because various startups was also growing at that time. So this MySQL database came into existence, and it was the very first open source database. So it was free of cost to use. And that is where people started adopting MySQL technology, or maybe the SQL technology, the RDBMS technology. So MySQL is a very, I would say it is the first love for any data professional who is trying to learn SQL as a language, because this is open source and this is very lightweight and it is having a very clean interface for anyone to understand. After that, the PostgreSQL came into existence. Now Postgres is also a open source relational database management system, but they solved a very different problem. When they launched themselves, there was a increase in the amount of textual data. So people started messaging. Now, since people were messaging, the companies are required to preserve that data also. And then they need some technology which can help them to perform textual search. So when PostgreSQL came into market, they launched very two unique functionalities. Number one, they gave user with the flexibility to perform full text search. And they came up with a lot of functions which can help you to perform full text search. Whereas they also launched a particular extension which they called as PostGIS. So this was the extension which can help the users to basically interact and analyze the geographical data. Now here we have one example of how we can use PostGIS framework. So let's say we have to find out what all places we have around a particular region. So here we have the latitude and the longitude, and I wanted to find out that what all places we have around this particular place in 10 kilometers or within 10 kilometers. And here you can see the sample code. So select asterisk, and this is the point of a particular place, let's say B. This is my A. Here we are calculating the distance, and then where we have written a condition where the distance is less than 10 kilometers. So you can see that with the introduction of PostgreSQL, these two tasks became very easy for users to perform. So let me just quickly summarize everything about how the development was made. So Oracle was the very first market player which came into existence, and they launched a particular SQL language which they called as PL/SQL. PL/SQL was a language which allowed the user to write down conditions, loops, and write down procedural logic. Then the next market player was SQL Server. Now they launched a particular technology known as T-SQL, which was very much simplified to work on transactional data. And then we were having MySQL, which was very lightweight and easy to connect with multiple websites. After that, PostgreSQL came into existence to basically help the user work with textual data and geographical data. That is how development was made. Now here I wanted to talk about two additional platforms which are not database but they are platforms, SQLite and Google BigQuery. Now SQLite is a serverless platform. Please remember, it is a serverless. It does not provide you a server. It is a serverless platform which you can download and you do not have to install. You can straight away start working with it. It is very lightweight. It performs very fast. So let's say you are looking to work on pre-development research. You are working on a database where you want to research. You're looking for very quick computation. SQLite platform is a very great alternative when it comes to MySQL or Oracle. It can connect to any server, but it is basically a client, which is very fast and efficient. Google BigQuery, on the other hand, is a cloud-based data warehousing analytical platform, which is available in cloud infrastructure. So you do not have to install anything. You do not have to basically work on managing the server. It is cloud-based, so you have to just pay for the services and you can use this particular technology. Now, this is basically a paid thing. If you wanted to work on Google BigQuery, you have to pay. But for a user who are trying to use this technology or maybe a platform for learning purpose, they can use it and they will not be allowed to connect to a server. So they can use the internal server or maybe the internal data which is present in this platform to play with various queries and to learn about it. So we'll be also using this. I'll be demonstrating you how the Google BigQuery looks like and how you can use it for your personal learning. But that was all about this particular video. In this video, as you guys already know, that we have discussed about a detailed theory and detailed history of how RDBMS technology happened and what all came into market and what all improvement were made over the period of time. So we hope now you guys are clear with the difference between various SQL platforms and the history of SQL. Before you end this video, please like this video, share this video with your friends and subscribe to our Scalers YouTube channel. I'll see you in the next video.